In this video, we want to evaluate the integral of arcsine of x dx. You want to give this a try? Go ahead and pause the video. I'll be right back. So I'll be using integration by parts for this one. Get my two functions u and v. U will be equal to arcsine. So we've got u equal arcsine of x. And then you can always multiply anything by 1. So my second function v would be 1. So put a 1 here and times that. So I should say the dv will equal to 1 or just dx. So for this one here then, du will equal to the derivative of arcsine. It would be 1 over the square root 1 minus x squared. So be dx here. And the integral here for dv would be v. Integral of 1 would be, say, x. So the formula for integration by parts tells you the first part of the answer will be whatever you get for u, in this case your substitution, multiplied by whatever you get for v after you integrate the second expression. So here we get arcsine in x, so those get multiplied. I'll put the x first. So that's the first part of the formula, and it gives you the first part of the answer. So it's u, which is arcsine of x, times the v, which is x, and then it's minus the integral of v du. So we have v is x, so this will be right here, and then du is over here. This will be 1 over the square root of 1 minus x squared. And this will be dx. So then all we have to do is integrate this part right here. And you've got to have an x in the numerator, and the denominator we have the square root of 1 minus x squared, and the derivative of 1 minus x squared is the 2x, so that's nice because we have an x on top here. So we don't need this part over here, and this is going to equal to, just rewriting the first part again, and then this one then will be minus, and then I got x over the square root of 1 minus x squared. And then I can solve this second integral here by a standard u substitution. So again, I'm going to use u, but in this case it's a separate problem. So think of u, I could use another letter using u. So u equal to 1 minus x squared. So du would equal to the derivative of 1 minus x squared. Derivative of 1 is 0, so this is going to be derivative of minus x squared is minus 2x. So then I want to transform this integral here into one involving u. So I'm changing the variable here, so x dx will equal to, divided by negative 2, this would be a minus 1/2 du. So then when I work this integral over here, so I've got the minus there, and I've got this minus 1/2, so the x dx, you can see x dx up here will be replaced by du times negative 1/2, or du over a negative 2. So either way, this negative will cancel here. So when we get the integral, I have a positive 1/2 out here. And then this would just be a du, and then 1 minus x squared is u, so this would be the square root of u. I write it to the 1/2. And I'll take that to the numerator, change the sign to a negative 1/2 for that exponent. So using the power rule for integrals here, I add 1 to the negative 1/2. That'll give me a 1/2. And then I divide the coefficient by 1/2. It'll be 1/2 divided by 1/2. This will be 1. And then this will equal to then u to the 1/2, or I could write that as the square root of u, and u is 1 minus x squared. And then I can come back over here and finish the problem. This will be equal to x arcsine of x, and then this will just be plus from this result over here, the square root of 1 minus x squared, plus your constant integration. So this is the final answer. X times arcsine of x plus the square root of 1 minus x squared. And I can put this in parentheses to make it more clear. Thanks for watching. We'll see you next time.